Okay, basic derivatives, chain rule, Lagrange's notation. So, what do we have? Forget about this for a minute and focus on the notation he uses when calculating the chain rule. So, he starts with a function, gx, within the function f of gx. Now, the first derivative of this function is when he derives the outside function but keeps the inside function the same. That's what this is. I'll show you in a minute. And he multiplies it by the derivative of the inside function. So, over here, you've got, let's just go back to the power rule for a minute. You've got f of x equals x squared. Now, the derivative of this function, f dash of x, is 2x, because you bring the 2 down and you take 1 off the power, which means power of 1. Now, if we were to replace x with gx and have f of function with respect to gx, just like function with respect to x, and then we'd have gx to the power of 2. Now, if we had the first derivative of function with respect to gx, it would be 2gx, because you'd bring the 2 down. So, just like here, you treat it the same way. You just first derivative of the outside function while keeping the inside function the same, and then you multiply it by the first derivative of the inside function. Now, to do some examples to help explain this, okay. So, start with fx equals 5 x squared plus 1 power of 10. Okay, so we know that in this case it's not just x to the power of 2 plus 1. If that was the case, you would just do the power rule, but because there's brackets and it's to the power again, you have to do the chain rule to solve this. Well, you could expand the brackets 10 times, but that would take a lot longer, and this is a much more efficient way of doing it. So, we know that f of x, in this case, equals the first function, which is the 5 and to the power of the 10, and then you have gx, which in this case is x squared plus 1. So, let's label that out. Gx equals x squared plus 1, and so f of gx, if we sub this in, would equal 5 gx to the power of 10. So, the first derivative of the chain rule following this notation is f dash gx multiplied by g dash x. Let's split those up. So, if we were to follow this, we would, let's say we derive gx first. So, derivative of gx is, bring the 2 down, 2x, power of 1, plus 0. So we just leave that out. Okay, so now we have gx. Now we need f dash gx. So we find the first derivative of this function. So f dash gx would just be the derivative with respect to gx. So we bring the 10 down, make it 50. Gx to the power of 9 because we take 1 off. Okay, now let's sub these in. Bring it down here so we have a bit more room. F dash x equals f dash gx, which is here. So we'd sub this in. 50 gx power of 9 multiplied by gx, which is, or g dash x, which is here. We'll leave the 1 out, so we'll just have a 2x. Now, if you want to simplify this, or the next step, you could sub gx back in. 50 x squared plus 1 to the power of 9 multiplied by 2x. And if you wanted to simplify it further, you can multiply the 2x by the 50. Because technically the 50 is just multiplied to this. You can separate it. We'd put a multiplication sign in the middle. So, we multiply the 2x by the 50, giving us 100x. X squared plus 1 to the power of 9. And that is the first derivative of this function up here. Okay, now for another example. Let's say example 2. 12 3x plus 4. So, over here, we would find out what our values are. So, we'll write the equation in again, just to make it easier. So, if we make gx equal to 3x plus 4, the inside the brackets, the function inside the brackets, then we could, let's put a power on this, make it power 4, otherwise we'd have a problem. So, to the power of 4. So, the inside function would be 3x plus 4, and then f with respect to gx would be 12 gx to the power of 4. Now, when we derive this, we get f dash gx multiplied by g dash x. So, let's find the derivative of gx, which would be just 3, because x to the power of 1, and that's a number. So, now let's find f dash with the derivative with respect to gx. So, f dash gx. So we'd bring down the 4, multiply it by the 12, which would be 48. Multiplied by gx, and then have it all to the power of 3, because you take 1 off the power. So now we have that, we can sub that back in. So, f dash gx would be 48 gx to the power of 3, multiplied by 3. We can simplify that further and multiply the 3 by the 48, which would give us 144 gx to the power of 3, and then we could sub back in gx. So 144. And then we put sub in the 3x plus the 4 to the power of 3, and that there would be the derivative, first derivative of this up here. Let's do another example. So, we would have fx 4 square root inside the square root x squared plus 4x, which we know equals 4 bracket x squared plus 4x power of a half. So now we can write out the formula. Fx equals f bracket g x bracket. And so over here we will write this in, I guess. F dash gx multiplied by g dash x. We were looking for these. So if we make gx equal to x squared plus 4x, then f with respect to gx would equal 4gx to the power of half. So if we're looking for the derivative of gx, that would just be 2x plus 4, and the first derivative of this function with respect to gx would be, you'd bring the half down, 4 over 2, or 4 over 2, because it's 4 multiplied by a half, multiplied by gx to the power, take 1 off the power, negative a half. So sub that in, and what you're left with is f dash of x equals 4 over 2 gx negative a half multiplied by 2x plus 4. So we can simplify this by subbing in gx, and simplify it further by 4 over 2, that's just 2, so 2, sub in gx, which is up here, x squared plus 4x, power of negative a half, multiplied by 2x plus 4. Now we can bring this under as the denominator because of the negative power, so that'll be 2 x squared plus 4x, and we can multiply this up and make it, put the 2x plus 4 up here, make that a half, and that there is the first derivative of this function up here. Thank you.